Now you understand the drivers of opportunity and technology innovation, it is time to look at how and where the technologies get developed. It is business that conducts the most research and development activity in the US and the UK. But government provides a lot of support. In the UK, the government provides R&D tax relief to firms who decide to locate their R&D facilities and jobs in the UK. This is a big incentive for firms to locate their facilities in the United Kingdom. Large government institutions like the Ministry of Defence or National Health Service are big customers for the products that are developed from this private sector research. The lone inventor is very rare, but it can happen. There are many firms in the oil and gas sector, particularly in Aberdeen, that have been set up by lone entrepreneurs. These are usually people who have left large organisations, but with real insight into their industry's problems, who then set up their own companies to sell them a solution. I was fortunate enough to coach one a few years back, Paddy Collins, who was an ex-employee of British Petroleum, BP. He used an MBA assignment to establish the fundamentals of his business plan. He eventually bought the company he studied in his dissertation from the owner, who was also the subject of his research into early-stage founders. Paddy realised that he needed the organisation to deliver his ideas, so found a very creative way of financing the buyout of Aubin Group Limited. He is now selling many solutions globally, breathing new life into an existing organisation. But it was a university course that helped him find the path. Universities help the process by training students with the fundamental entry skills for a scientific career, or equipping people with advanced research or management degrees to help equip them for leadership roles in large organisations. They also conduct research, and despite a drive to commercialise it in Scotland, the results have been pretty poor, with some major public failures. The US are much better at this, and I was fortunate enough to experience this firsthand during my research with startups from MIT and Boston. Their technology licensing operation was extremely effective in the way that it engaged business, trying to understand their problems rather than trying to get them to buy intellectual property or university spin-out companies. They really were very customer-focused. In the US, and the same is true in the UK, the government influences the science agenda by deciding where to invest money in public sector research. It tends to be dominated by life sciences and physical sciences because they are the most likely to create technologies that have real practical application. In the United Kingdom, it makes sense if the beneficiaries of this research and new products are likely to be the Ministry of Defence and the National Health Service. Progress in life sciences and physical sciences has immediate practical application in these institutions. The US has a long and increasing commitment to fund public sector research. The basic philosophy is, if you invest in science, you create the people and raw materials for the technology businesses of the future. The UK invests significantly too, but having seen both in action, the US universities seem much more commercially focused, and that is probably why their startups are so much more successful. I think it also helps that they have access to one of the biggest global markets on their doorstep and all of the infrastructure that goes with it. Crossing the chasm to the mass market is much easier when the market and the infrastructure pretty much already exist. Research and development in the private sector is a deliberate attempt to invest in their own research so that they can own and appropriate the returns. R&D is a long-term investment in the future of the business. It is a fairly straightforward model. You invest in research. That research results in an invention. That invention may not have any practical use initially and is dependent upon it finding a practical application. At that point, it becomes an innovation. That innovation then finds application in a product, process or service. Only when that final product is sold does it result in any revenue for the company. R&D is a resource-intense activity, and different firms manage their innovation strategy in different ways. It tends to be the larger the firm, the more they invest in the upstream theoretical research, because they can afford to wait for the long-term payback. Younger firms have to focus more on applied research or development in areas where there is a chance of a more immediate payback. There are three main categories of R&D. basic research. Research into the fundamental science, new theories, formulas, and these will be years away from practical application. It was from this type of fundamental research that Aerial Future had its origins. I can track it back to two purely academic papers published in the 1970s. Applied research, focused on generating a new development in science to better define a problem or solve a known technical issue or performance deficit in an existing technology. That was what my PhD was about, taking that theoretical research and using it to understand and measure pollution in soils. The R in R&D is generally applied research. Very few firms invest in basic research. Development research. The D in R&D is development. It is about application of technology to solve a specific problem. With Aerial Future, the development activity was using the scientific formulas I had developed in soils to perform calculations to help us understand which chemistries would work best in a detergent context. The innovation was the actual detergent. The invention was the calculations I was able to develop to make it possible. Research and development is a calculated investment by technology firms to create technologies that will improve the performance of the products, to reduce the imminent risk of substitution by emerging technologies. You cannot stay still in technology products. Someone will always catch you up if you do. It differentiates products from competitors. Truly scientifically proven, superior performance can be claimed in TV advertising or can result in patents being granted. And the R&D team can bring in technologies from outside that could never be brought in or understood by non-technical people. If we look at the companies that spend most on R&D on a global basis, only one of the top 20 R&D spenders is a UK company, GlaxoSmithKline. The list is dominated by big pharma, automobiles and electronics firms. The UK does well in terms of R&D activity, but most of the firms are owned by overseas corporations. Investment in R&D varies vastly by sector. In food, it is low. In PepsiCo, I had to fight for every penny, and I ended up creating businesses within the business, selling my services globally within the company to bring in money because food firms do not invest in long-term research, or very few do. I had to create opportunities to make money, and then I reinvested that money into developing the next generation of R&D capability. It was a great experience to equip me for what I'm doing now. It taught me the best way to raise finance is by selling something. Sell something, make some money, and then use that money to invest in future research capability that you know will create the next generation of products. Levels of R&D investment vary dramatically across different industry sectors. I've already mentioned that it's very low in food, but in the chemical sector where P&G operates, investment is 10 times higher. In P&G there was real money to fund R&D projects, but you had to demonstrate it had application in final products. The payoff could be 2 to 3 years away, so it was very much more focused on the mid to longer term product opportunities. The highest investment in R&D is in scientific and technical services. Here you are seeking a practical solution to a current problem, so it is good use of funds because it is focused on a market solution that is required right now. In the UK, R&D is heavily invested in pharmaceuticals, with defence second, but not much ahead of the other sectors which are dwarfed by pharmaceuticals. So what are the costs of R&D? Investment in R&D is risky, but so are the financial markets. At least with R&D, you are at least creating assets in people and technology. Payback is not short term. It tends to be 2 to 5 years, or even further in the future. It can be 10 years plus in the pharmaceutical and defence industries that engage in much more upstream fundamental science research. It tends to be that the big payback comes from a very few projects that have enormous impact. Once you get into R&D, it is easy to get locked into the capability you have created in the previous paradigm. It is often hard to translate R&D into market value. Was it really the invention, or just great marketing or superior negotiation on margins by the sales force that generated the profits? R&D is so early in the process, it is hard to determine its value. With Aerial, it was easy, but that was a one-off for me. With Aerial, it was all about stain removal, and without the technology, it would not have been possible. And the advertising reflected that. Believe it or not, the average R&D project failure is 80 to 90%. Robert Cooper's stage gate process helped P&G get that down to 50%. The smaller the firm, the more D, the less R, if any at all. I take quite a simplistic view of R&D beyond the usual pros and cons arguments. It creates assets, people, patents and technology, all of which add value to your business and that you can sell. Does research lead to development? If it is hard to link R&D to profit, it gets even harder trying to relate research to development. Your basic research is supposed to be speculative, but it is often driven down a focused path because it is tied to your current development efforts. The most talented scientists do not work on development. They do not see it as intellectually challenging enough. Transitioning from research to development is very difficult, as it often requires major re-engineering of the original technology to do something it was never actually designed to do. A lot gets lost in translation as it moves down the R&D pipeline. I've heard of numerous stories and anecdotes where technology failed down the line because a fundamental piece of data was not transferred from the research team to the development team. Academics are often so far detached from reality they may as well live in a parallel universe. I've had some very bad experiences where I have paid them to do a very specific job and they have gone off and done something completely different without telling me, and then cannot understand why I am angry and do not value the shiny invention they have created that bears absolutely no resemblance to what I asked them for in the first place. How you conduct your R&D is dependent upon your business strategy. There is no one-size-fits-all design. You have to develop an R&D strategy that is in line with your business objectives. How you do it affects your margins. Spend a lot on risky upstream development work and it will hit your margins because it is speculative effort and costs a lot of money. Good R&D can help sell your product to customers. But there is another way. You would be amazed at how much you can outsource if you carefully manage the intellectual property agreements.